Okay, so I'm looking at the series where I'm adding up 1 divided by the square root of n. My first value of n is 1, and then I just go through all of the whole numbers off to infinity. So 1 on the square root of 1, plus 1 on the square root of 2, plus 1 on the square root of 3, plus 1 on root 4, 1 plus 1 on root 5, and so on. Does this series converge or diverge? Well, let's try this partial sums idea again. So again, we probably gave this to a calculator or a computer to do for us. If I added up 5 of those numbers, I'd get 3.23 and change. If I added up 10 of them, I'd get 10.502 and change. Add up 50 of them, we get 12.75 and so on. Add up 5,000 of those, right? The first 5,000 numbers in that list. Start at 1 divided by square root of 1, go all the way up to 1 divided by the square root of 5,000. Add them all up together and you will get about 1.39.96. Now, the list here does not seem to be converging, right? I would expect this to slow down over time, to stick to one particular value on the real number line, but I don't see that here. So this time, we're going to draw a slightly different picture because I think that this sum actually diverges. So again, I'm taking this formula from the series and I'm using the continuous variable x instead of just saying the formula is only for whole numbers n, right? This formula still works for any positive real number. And that curve is going to look something like this. It does not decay nearly as fast as the 1 over x function. And now I've done that same trick of drawing all of these rectangles where the width of each rectangle is 1. The height of each rectangle is just the value for the nth term of the series. So first 1 on root 1, second 1 on root 2, third 1 on root 3, and so on. And I've done the same idea of just lining them all up on the x-axis. But now what I've done is I've shifted them over by 1. That's fine. I can shift things left and right on the x-axis. But the result of that is now it's not the upper right-hand corner of these rectangles that hits the curve 1 on root x. It's the upper left-hand corner, right? This is coordinate 1, 1. This is the coordinate 1, 1 on root 2. This is the coordinate 2, 1 on root 2, then 3, 1 on root 3, then 4, 1 on root 4. Those are all xy pairs. And they all lie on this curve y equals 1 on root x. Well, that would mean that whatever I get for the improper integral here, right? If I integrate 1 on root x, starting at 1, going off to infinity, that is an improper integral. And that is going to be less than the area of all of these rectangles. So if I do this integral and I get, say, positive infinity, I know that the series also has to go to positive infinity. It also has to diverge.